and good day, geometry. Today we are doing geometric proofs involving segments and angles. We started proofs, the two-column format with equations. It's something you're kind of familiar with, but today we'll be using strictly geometric reasons, definitions, properties, postulates, and theorems to explain why things are the way they are. And so this does open up with a fair amount of writing. So our wrist exercises, wrist up, forward, back, round and round. We don't want any cramps, okay? And here we go. So proofs are really all about answering two questions. The first is, what do I know? Okay? You should approach every proof by looking at what it tells you. What in the diagram is marked? What's your given statement? Okay? What do you know? All right? And then number two, this is the meat of it here. What can I conclude? Okay? Based on the information that you know, what conclusions can you make? And that's going to help you kind of weave your way through the proof to the proving statement. And being a formal geometric proof, we're not going to be using inductive reasoning here. We'll be using deductive reasoning, which, remember the difference, deductive is factual and logical. So we're only allowed to use definitions, properties, postulates, and theorems. We already have some experience with properties, the addition property, the division property, right? We've done definitions before too, actually. We've defined what combining like terms is, postulates, the segment addition postulate, the angle addition postulate, and even theorems. So we've kind of talked about all four of these things, but these are the four things that we're going to be using. Okay? You ready? Yep. Let's go. All right. So the first one we're going to talk about are a few properties, and we've got the reflexive property of congruence. And what this means is that A, so you have something, an angle, a segment, or whatever, call it A, to itself. Aren't you glad you came to learn this? Earth-shattering news. A is equal to A. And we'll use this more so when we get to triangles. So I do want you to star it, because it's actually one that you're going to really, really like, because it's really, really easy to see, and it's a good one to use. But we're not going to use it yet, but it will come back later on. But basically, if you've got segment AB, the reflexive property tells you that it's equal to itself. If you have an angle, angle A, then that would be equal to itself. Okay? Generations of very smart math people have come before you to bring us this. Okay? The symmetric property, if you have something like A equals B, and actually we're going to write this as a conditional statement. So if A equals B, the symmetric property tells us that B will equal A. If A equals B, then B equals A. Okay? And the reason why we have this one is if you flip the page, you'll see that you are given a specific proving statement. In the four proofs that we'll talk about today, you have a given statement and a proving statement. That proving statement needs to be in that specific order. Okay? So for example, if your job is to prove that x equals 7, and the way that you solve the equation, you come up with 7 equals x, those aren't the same thing technically, right? So if you were to come up with 7 equals x, and you were supposed to have x equals 7, you would use the symmetric property to simply flip it around to put it the way it's supposed to write. This is kind of the annoying one. This is the one that Mr. Schultz always got wrong when he was in high school learning geometry, because I just didn't want to do it. And so I would hand in a test knowing I would get it wrong and just didn't care. But you won't do that. You will be better than me. Yes? Oh, I thought you had your hand up. Okay. So that is the symmetric property. The transitive property, and I want you to star this one as well, because this one you will use very, very frequently, says that if A equals B, and A equals C, can you predict how this is going to finish? If A equals B and A equals C, then B equals C. Okay? If the same thing is equal to two different things, I should use black on that actually. Make 4 different colors here. Okay? If the same thing is equal to two different things, then those two different things are also equal. Okay? The transitive property. If A is B and B is C, then A is C. Yes?
So, like, what would an example be?
So an example of this. I actually use this. Actually, no, I'm going to bring it down. I use this to teach about the zero power for exponents, but since you haven't had that background, that's probably not going to be the best example here. So let's look at this. If 5 minus 4, not equals 4, if 5 minus 4 equals 1, and 3 minus 2 equals 1, then what can we say about 5 minus 4 and 3 minus 2? They're the same, right? So if 5 minus 4 is 1 and 3 minus 2 is 1, then 5 minus 4 equals 3 minus 2. Because they both equal 1, therefore they have to be the same also. Yes, teacher win. Okay, that's kind of the transitive property. Okay. Question so far? Okay. Next one, what do we got here? The right angles congruence theorem, which can abbreviate to be the RACT, the R-A-C-T. Here's a pro high school tip. If you want to be part of the cool group, you would call this the RACT. You know, walking to math class, first day, hey, you heard of the RACT? Yeah, I've heard of the RACT. I use the RACT, you know? So, but what it says is that all right angles are congruent. The right angles congruence theorem says that all right angles are congruent. Okay? The congruent supplements theorem. Okay? The congruent supplements theorem. If angle A is congruent, actually no, I'm going to reword that. If angle A is supplementary to angle B and congruent to angle C, so angle A is supplementary to angle B and congruent to angle C, what does that tell us about angles B and C? So you've got angle A and angle B, which are supplementary. You've got angle C over here that is congruent to angle A. What does that tell us about angles B and C? They are supplementary. Okay? Then angles B and angles C are supplementary. Kind of a cousin to the transitive property. You know, you kind of got that 3-part relationship here, but not exactly the same. It's not with equality necessarily with supplementary angles. You with me so far? Yeah. Within shouting distance anyway? No one's walked out of the room yet? All right, that's okay. The second page, congruent complements theorem is going to be very similar to the congruent supplements theorem, only with complementary angles. So if angle A is complementary to angle B and congruent to angle C. So in this case now we've got complementary angles. So we got a right angle here. Here's A. Here's B. Then over here, ooh, those don't look congruent, but they are because they're marked. There you go. Okay. So A is complementary to B and congruent to C. What do we know about B and C? Lucas? They are complementary. Okay. Questions on either of those? All right. The vertical angles congruence theorem are abbreviated the VACT, or just the VAT, the vertical angles theorem. What are vertical angles? We talked about these before, back in PO7, I believe, or earlier. What are vertical angles? Right, they're angles that are across from each other or opposite each other at a point of intersection. So an example would be angle 1 and angle 2 there. And what do we know about vertical angles? What's their relationship? They are congruent. Okay, so the vertical angles congruence theorem says that vertical angles are congruent. There's something else I want to say about those, but now it escapes me. Oh yeah, start this one because you will use it often when we get to proving triangles are congruent. So the part of the anxiety with the other group with proofs was that it is challenging. Like I said, tying your shoes used to be challenging too. You just need more practice. So the point of PO16 is not for you to master proofs. Okay, we are going to go over at least 3 proofs today in their entirety. Your homework is going to be more like fill in the blank style, where some of the proof is done for you, and you just need to fill in the missing reason or the missing statement or whatever. Your test is going to be the same thing. Okay, so I'm not looking for a mastery here. This is just the basics of it, right? We'll do more proofs as we get more theorems, more tools to our toolbox. So don't expect mastery here because I don't expect mastery here. Okay, is that the last one? Oh, there's more. Linear pair postulate. What is a linear pair? That's back in PO7-ish 2, linear pair. Yeah? 2 angles that make a line, right? And the linear pair postulate says that, how do I say, 2 angles that form a linear pair are supplementary. We kind of already knew that, just like we already knew that vertical angles are congruent, but when you're doing a proof, you can just say that fact, call it the LPP. You know the LPP? I don't know the LPP. Okay? Linear pair, 2 angles, angle 1 and angle 2. We know they are supplementary because of the linear pair postulate. Okay? Okay, and we are back. So there's your kind of start of your definition postulate theorem list. These are other things we've talked about too. We've talked about the segment addition postulate, or SAP, in CO2. We talked about midpoints and angle bisectors there. This was cool for a while, the definition of an angle bisector, the DAB. Okay. But then we have the angle addition postulate. These we didn't talk about specifically, but quite frankly, unless it has a specific name, like you wouldn't write a proof and say postulate 10, because no one knows what that actually is. But they are postulates. Just good to know. We already talked about their relationships. The properties of equality, which we talked about, and substitution. I want you to star this one too. I think I had you start on CO15 binder page itself, but you will be using that one quite often as well. And every time that we learn a new definition, postulate, or theorem, you're getting a new tool for your toolbox, right? That's what we are feeling here. Okay, so that when you work through a proof or you work through a geometric problem, there are oftentimes many different ways to get to the answer. And the more tools you have, the more opportunity you have for success. Okay, maybe you can't find the tool that would work best, but there are roundabout ways. If you're trying to pound in a nail at home, you can't find your hammer, could you use a screwdriver? Yeah, it'd work eventually. Might not be the best thing to use, but it would work. So that's what we're doing here, building this toolbox. Julia. You already know what they are. They're not named because they're not like super duper important. But it says like one of the earlier postulates, 5, 6, 7 of that, says that between any 2 points you can draw a straight line. Right? We already know that. Okay. You aren't going to use that in a proof. But it's just some geometric relationships that exist. We talked about most of them already in CO1. But if you want them, they are in your textbook. I think chapter 2, section 3 or 4 or something like that. You're welcome. All right, enough beating around the bush. Let's go. Let's do some proofs. I need to write larger than I would if I were doing this on the piece of paper, just so you can see it. So I might have to do like half the proof here and then slide over and do half the proof there. But for you, try and make everything fit kind of in this range here. Just keep it organized. So here we go. This first one. We're given this diagram of 3 lines. We've got angles 1, 2, 3, and 4 labeled. We're told, remember that first question, what do I know? We're told that angle 1 is congruent to angle 3. And from that, we have to walk through how we can conclude that angle 2 is congruent to angle 4. So we're going to start by making our statement and reasoning chart. Statement, reason. Well, don't growl already. This is like the easiest part, is making the chart. Everything after this is what's hard. Okay? And our first statement is going to be what we're told. What do we know? We know that angle 1 is congruent to angle 3. And how do we know that? Because it is given. It is our given statement. Okay. Now, if we are going to prove that angle 2 is congruent to angle 4, I say that we have to include angle 2 and angle 4 in our proof. We have to invite them to the party, right? We have to say, what do we know about angle 2? So here's where we look at the diagram. We find angle 2, and any relationship that we can come up with involving angle 2, it might be helpful, might not. I'll guide you in that respect, but anything you can say about angle 2. Julia. Okay, that's good. Because whenever we can introduce something new with something we already have in the proof, that's usually the right process to use. So step 2, we can say that angle 2 is congruent to angle 1 because of vertical angle theorem. Or the VAT, if you want to write that down. If you write VAT, I will know exactly what you mean because I sat at the cool table. Okay. How about angle 4? Let's introduce angle 4. Any relationship you can see with angle 4, Audrey?
Angle 4 and angle 3 are.
Okay, and we don't even have to make a new step for this to say that angle 4 is congruent to angle 3 because it's the same reason that we just said. You know, angle 2 is congruent to angle 1, angle 4 is congruent to angle 3, for the same reason, the vertical angle theorem. So we don't have to create a whole new step because the reason's the same. That make sense? Okay. Julia, do you have a thought? They don't make a line, they're part of the same line, but angles that make a line have to be adjacent angles, right? So if we labeled this angle 5, we could say that angle 1 and 5 make a line because they're adjacent and together they make that line, but not 2 and 4, okay? But let's look at what we have here now. Let's take a step back. We've introduced angle 2 and angle 4, so they're part of the proof now. We said angle 2 is congruent to 1, angle 4 is congruent to 3, and we know that 1's congruent to 3. Now, in our heads, we can kind of, just think, okay, well, if 2 is 1 and 4 is 3 and 1 is 3, then 2 is 4, right? It kind of makes sense. Unfortunately, there's no geometric theorem that relates 4 things together. You know, A is B and B is C and B is D, so A is, right? That's not how it works. The transitive property is the best thing we have here. So we have to kind of narrow this down to just 3 angles, okay? So let's look at our statements here in statement 2. 2 is 1 and 4 is 3. Let me look at the 4 is 3 here. Can I rewrite this? And I'm going to highlight it, box it in red just so you see. You don't have to do this in your proof, just so you know what I'm working with here. Can I rewrite that statement to be angle 1 is congruent? Oh, sorry, hold on. Angle 4. I mean angle 4. Angle 4 is congruent to angle 1. If angle 4 is congruent to angle 3, and angle 1 is congruent to angle 3, isn't 4 congruent to angle 1? Yes. And why is that? There's actually 2 of them that you could use here. What's the one that relates 3 things together? That's why I focus on just that one. We have got 3 things, A is B, A is C. So B is C. Transitive. Okay. Or you could also, since I literally just replaced angle 3 with angle 1, knowing that angle 1's congruent to angle 3, I replaced angle 3 with angle 1. That would be the substitution property, right? I substituted a value for, I don't want blue. I substituted a value, it's crashing down. Okay, I substituted a value for another. So either one works there. You don't need them both, but transitive or substitution. Okay, good so far? Yeah. All right, so now step 4, and I'm going to go over here because I ran out of space. Hopefully you still have some room, okay? But step 4, let's look what we have here. I just wrote that 4 is congruent to 1, so I probably want to use that going forward. You want to write things with a purpose. So what other statement that I have here can I use along with 4 is congruent to 1 that'll allow me to say that 2 is congruent to 4? Audrey? Let me read. What statement do I already have written? So of those 4, which one can I kind of combine or use with this one here that will actually allow me to say in my 4th step that 2 is congruent to 4? Olivia? Right. If 4 is 1 and 2 is 1, 2 different things are equal to the same thing, therefore 2 is congruent to 4. You see it? Audrey, no? Okay, so let me use the diagram up here. So do you accept that angle 2 is congruent to angle 1? Yeah. So I'm going to mark these congruent up here, right? Angle 2, angle 1, or angle 1 and 2. Follow me? Okay. Do you accept that angle 4 is congruent to angle 1? Okay. So we'll mark angle 4 and angle 1 congruent as well. Well, if 4 is congruent to 1, and we already said that 1's congruent to 2, that means that 2 is congruent to 4. Right? And the reason why I can say that in step 4, that angle 2 is congruent to angle 4 is because of the I formed a relationship here between 3 things, right? 1, 2, and 4, transitive property. The transitive property is a good one to know. Because it's one that you will use often. Congratulations. You've just done your first proof. How's it feel?
Bad, because I have to do it more.
Well, okay. It's not very positive thinking, right? If you were able to get something away from this, that's okay. You know, like I said, I'm not expecting mastery here. But if you're able to see, oh, that's why we used transitive here. Or, oh, yeah, I can see that they're vertical angles. I understand how we brought in angle 2, how we brought in angle 4. That all makes sense here, okay? Then you're in a good spot, all right? Questions on this before I erase it and go on to the next one? Okay. The next one. It says angle ABD is a right angle. So locate ABD, okay, from point A over to point B and down to point D. And it says CBE is a right angle. So from point C up to point B, down to point E. And our job is to prove that angle ABC is congruent to angle DBE. And ABC is kind of this, from A to B to C, this angle there. DBE is this one over here on the right side. Okay. Now, one of the reasons why I'm not going to post the recording from the first group and why I plan to post the recording from this one is because when you start labeling angles as letters and you're writing a whole bunch of things with a whole bunch of different letters, what can happen very, very easily? Things can get confusing, right? ABC plus BCE plus XYZ plus I don't know what I'm doing anymore, okay? It just gets very, very cluttered. So one trick you can do is label these angles with numbers. Angle 1, angle 2, angle 3. This is not technically geometrically legal to do necessarily. Technically in a proof we should keep if they're introduced to us as letters, we should keep them as such. But again, we're just learning the basics, so we're going to keep it as simple as possible. So essentially, what we're looking to do here, angle ABC is angle 1, DBE is angle 3. We're looking to prove that angle 1 is congruent to angle 3. Is that easier to see than the letters? Yeah. Okay? So let's make your statement and reason chart. Now that we're pros at this, we can just abbreviate S and R because we're proof veterans. Okay? And what is our first statement? What do we know? The given. Okay? Now, ABD, since it includes angles 1 and 2, this one we should keep with the letters. ABD is a right angle, and CBE is a right angle. And that is because they are given to us. So I've abbreviated right angle to be RA, just save some space. If you want to write the full words out, fine. If you know what RA stands for, if you're going to look at it later, maybe you want to circle this and just write RA here so you know what you're talking about, but just to save some space. Okay. Like the last one, we're looking at this, and we know that we have to somehow introduce angles 1 and 3, right? Because that's what we need to prove, that they're congruent. So, what relationship can you name involving angles 1 or 3? Yeah.
Do angles 2 and 3 have to be 90 degrees?
Why is that?
Because CBE is a right angle, and angles 2 and 3 are kind of like inside of that.
Okay, so angles 2 and 3 they make a right angle. What's another word that we say to show that the 90-degree relationship?
Complementary.
Okay, so angle 2 and angle 3 are complementary. Okay, and our reason for that, we could say the definition of a right angle. That 2 and 3 make up that right angle. The right angle is 90 degrees. Therefore, angles 2 and 3 are complementary angles. What can we say about angle 1? What do we say about angle 1? Julia?
Angles 1 and 2.
Okay. Angle 2 and angle 1 are complementary. And we don't have to make a new step because it's the same reason as we just had in step 2. But I'm already out of space, so I'm going to jump over here. Okay. So angles 2 and 3 are complementary. Angles 2 and 1 are complementary. We did introduce a theorem today involving complementary angles. What'd that say? The congruent complement theorem. Yeah?
Says if angle A is complementary to angle B and congruent to angle C, then angle C and angle B are complementary.
Okay. We can kind of use that same idea here because notice what we have here. 2 and 3 are complementary and 2 and 1 are complementary. If we can say that angle 2 is congruent to angle 2, what does that mean about angles 1 and 3? If both pairs of angles are congruent, right? So here we have, and I'll draw a separate diagram here. So we have, I'll make a right angle. That will make sense here. So I have angle 2 and angle 3. And then coming off of this, I'm going to draw it separately just so you can see it. But coming off of this, we have angle 2 and angle 1. So 2 and 3 are complementary. 2 and 1 are complementary. That's kind of what we have going on up here, only they're on top of each other. So if we can say that angle 2 is congruent to angle 2, what does that say about 1 and 3? They have to be congruent as well, right? Because if 2, and I'm just making these numbers up, if 2 is 70 degrees there, that means 3 has to be 20 here, right? Because they have to add to be 90. If 2 is also 70 degrees here, well then 1 has to be 20, right? And what theorem, property, definition, whatever, allows us to say that something is congruent to itself? I'm so excited we got to use this. We actually went a different route in the blue group with this, but I'm glad we're going this because I like to use this one because it's so obvious. Yeah.
There
the reflexive property. But the value of saying that 2 is congruent to itself, we can now say that angle 1 is congruent to angle 3 because of the congruent complements theorem, or the CCT. And I'll write what that is down here. Congruent complements theorem. Not exactly the way the CCT is worded, but it's the same general idea of it. How are we doing? Okay. Lucas, haven't heard from you in a while. Everything good?
I want to go home right now and still do geometry.
Okay. All right. We'll get through one more proof before the day is done. We'll do the next angle one, and we'll just leave the midpoint one. Maybe we'll get back to it a different day. Maybe not. We shall see. Okay. So for this one, we're given that 1 is congruent to 3, and they're labeled there. They're numbered, labeled. The arcs are in there. So that's all there for you. And our job is to prove that EBA, which is 2 and 3 together, angles 2 and 3 together make EBA, is equal to DBC, which is 1 and 2 together. So a similar situation as we had in the last one, where we've got an overlapping angle. That angle 2 is part of both EBA and DBC, but we have to go a different route for this one than the last one because we don't know anything about complementary angles or right angles. None of that's marked. Okay, so we will be going a slightly different route than we went with the last one here. But we start the same way as we always do. There we go. With our statement reason chart. And we begin with what we know. We know that the measure of angle 1 is equal to the measure of angle 3. We know that because it is given to us. Okay. All right. Let's introduce EBA or DBC. What do we know? Yeah. They are. And that's what this given statement says. Saying that the two measures are the same is kind of the same thing as saying they're congruent. So yes, they are. Let me get started. The measure of angle EBA is equal to what? Tell me anything you can see about the measure of angle EBA. Olivia.
It's equal to DBC, the measure of DBC.
Oh, that's what we're trying to prove, right? So we don't know that yet. That's what we're trying to get to. Right now we're just introducing EBA. Audrey.
It's equal to the measure of angle 2 and angle 3.
Good. EBA is equal to angle 2 plus angle 3. Right? You look at EBA, tell me anything you can about it. Well, I don't know much, but I do know that it's the measure of angles 2 and 3 together. And what postulate definition theorem allows us to say that the parts of an angle add up to be the whole? The parts of an angle add up to be the whole? The angle addition postulate, or the AAP. Okay, I'll write that out. Angle addition postulate. Okay. Can we do something similar with DBC? Tell me what you know about DBC. Alex?
It's equal to the measure of angle 2 and 1.
All right. And we don't even have to make a new step because it's the same reason as we had in step 2, the angle addition postulate. Okay. I like what I'm seeing here. Why do I like what I'm seeing? It's because I've introduced EBA and DBC, and I've got some relationships going on here between angles 1, 2, and 3, right? They show up a lot, you know? Angle 1 is equal to 3, EBA is 2 plus 3, and DBC is 2 plus 1. So I want you to use substitution to rewrite that statement, okay? This is kind of what your homework will be. It'll give you something to kind of fill in. Using substitution in step 3, I want you to rewrite that equation there. So we're still saying something about the measure of angle DBC, but instead of saying it's angle 2 plus angle 1, what else can we say about it that's going to lead us to the goal of comparing EBA and DBC to be the same? And again, you're using substitution, so you're replacing one of those things. Right? That equation kind of has 3 parts to it. It's got angle DBC, which I've kind of already told you isn't going to change. So between angle 2 and angle 1, replace one of those with something else to rewrite that equation. Any ideas? Lucas? What?
Never mind.
Okay. Audrey?
We could replace angle 1 with angle 2. I mean angle 3.
Yes. We're going to replace angle 1 with angle 3. We can do that because we were told that angle 1 and angle 3 are equal, right? So if DBC is 2 plus 1, then DBC has to be 2 plus 3 because 1 and 3 are the same. Okay? Now, what have we just done here? Why was that a major step to victory? Audrey?
Because angle 2 and angle 3 also equal EBA.
Yeah. DBC is equal to 2 plus 3. Well, guess what? EBA is also equal to 2 plus 3. See where I'm going with this?
Yeah.
What? Tell me.
I don't know what to say.
Julia?
Is the measure of DBC equal to the measure of EBA?
We can go straight there. Yeah. Step 4. Look, I actually fit the proof in the spot provided. We can say that the measure of angle EBA is equal to the measure of angle DBC. Because if EBA is 2 plus 3 and DBC is also 2 plus 3, then EBA has to equal DBC because of the starts with a T, ends in transitive. Transitive. Awesome job, folks. Very good. Whenever you are in the situation where you're comparing 3 things, EBA, DBC, 2 plus 3, those are 3 things, it's likely going to be the transitive property. All right. 3 victories in a day. I chalked it up to a good one. Feeling okay?
Yeah.
Okay. Your homework is going to be to kind of fill in the blank style. It's going to give you a number of proofs that have already been kind of started, and you just need to finish them up. And quite frankly, I forgot what I gave the other class. Uh-oh. Well, no, that's not what it means. Doesn't mean no homework. This means I'm gonna have to look back and see what I gave them. But I think it was page. We're gonna go with 116. Page 116. And I would like you to do 3, 4. Oh boy. 3, 4, 21, and 22. So only 4 of them. 3, 4, 21, and 22. I think I gave more to the other group. What else would I have given them? Yeah, otherwise there are ones on the back shelf too. Yeah, so let's just keep it at that. 3, 4, 21, 22, you are filling in the blank for proofs have already been started. That, folks, is how you math.